thanks for coming. Today we're going to talk about virtio-fs, which is a new file system for virtual machines. It's a shared file system. The point of virtio-fs is to pass through a host directory into the guest so that the guest can access files that live on the host. And the semantics that we're going for, the goals, is that it needs to be a POSIX file system so that existing applications can run correctly on it. And we do want the modern extensions, things that the Linux VFS has. And we want to have concurrent access from multiple guests. And we would like to give them local file system semantics, which means coherency where possible. And currently, virtio-fs has achieved some of these goals, and it's still under development. And you know, this is the goal that we're striving towards. The project was started in 2018, and since then we've published the source code, and Dave and Miklos and Vivek and I, we work on the QEMU implementation of this and the Linux kernel guest drivers. But the community has also started implementing virtio-fs in other hypervisors and also writing other file servers for it too, because it's actually an interface that you can implement yourself. Okay, so before I go too deep into what it is, I'd like to quickly tell you about the use cases for why we even need this, what the requirements are. First of all, we have lightweight VMs and container VMs, which are now becoming popular. Things like micro VMs, kata containers, and function as a service. Although these are the different things, they're not the same. They do have similar requirements. Those requirements are fast boot times and low memory overhead. And basically what they do is they need to access host files, because for containers, typically the container images are coming from the host. Because if you have a guest in a container VM, that container VM may be short-lived. So the container image does not live in there. It lives on the host. And there's also dynamic configuration files that get generated per VM by your container runtime. These might be things like etc resolve conf or whatever. They're not part of the container image. They need to be generated at runtime for each container. So how do we get it in? Well, if we have a pass-through file system, we can do it. We can get it into the guest and then into the container. Actually, kata containers merged virtio-fs support as an experimental feature in 1.7. So it's already available if you want to play with kata containers. You can give it a try. The next use case is file system as a service. And here the idea is if you have a cloud and you want to provide file system volumes to instances in that cloud, you can already do it. If you use, say, NFS or Gluster or Ceph or any other network attached storage type of technology. But the problem is if you do that, then the guests have to have access to your storage network. They have to have the configuration in order to be able to log in and get to their storage, which means you're limited now. You can no longer migrate away and say you decide to change from NFS to Ceph, because you'd have to change all of your guests. You'd have to go into the guests, which you don't even administrate, which you don't even own. So what virtio-fs can do for you there for file system as a service is it can be a layer of indirection. You can use it as the interface. The guest sees a virtio device. It does not know about the storage network. It does not have to have the configuration details to log into your Ceph cluster and so on. So that makes it attractive for doing that kind of use case. And then the final thing is just traditional virtualization. We want to be able to take a host directory and say, make it available in my VM, let me mount it. The reasons for doing this are for development, for getting files into a guest early on, maybe when you need to install some things and you're setting up your VM, but also for things like booting from a host directory, just creating essentially a chroot on the host and using that as the root file system for your guest, not even using disk images anymore, just being able to do a pass-through file system, which is very neat, because if you want to recompile software or kernels on the host and then quickly test it inside a guest, this is great. You don't need to build disk images. Yeah, so some special requirements, what's unique about this is it's important to be able to offer this kind of functionality in an automated way that doesn't require manual steps. That means not having to add a network adapter, not needing to assign IP addresses and configure NFS and so on. And that's doable with virtiofs because the configuration is very, very simple. That means libvirt and other tools can implement this as an automatic way so that the user just says, please share this directory, and it's like, it just works. Okay, so we had these requirements, and we were thinking about what to do, but why did we decide to start virtiofs? And the main reason is because QEMU and KVM need a production quality shared file system. Virtio 9p has been around for a while, but active development stopped in 2012. Active maintainership stopped this year, so it never reached the kind of production quality that we were looking for. And in addition, we had been thinking about some new ideas for how to go further than just using a network file system between a VM and a host. What can we do if we take advantage of the fact that a VM and a hypervisor are co-located on the same machine? Network file systems use message passing. They send requests and responses to each other. But as we're going to see later on, virtiofs has some features that go beyond that, things that you can't do in a network file system to get advanced features. Okay, so I'll give you a quick overview of the architecture. virtiofs is built on Fuse, so we didn't invent a new protocol, a new RPC protocol. We used the Linux file system user space infrastructure that's already there, but we extended it. And in order to use it for this use case, it's actually not compatible with, say, SSHFS and existing Fuse, and we'll explain the differences soon, later in the presentation. But it's based on Fuse, and it reuses the client code, which has been great. And then there's a virtiofs device, which is a new Virtio device that has been defined, that we've put into the spec. And on the host side, there's a daemon, there's a file server that handles requests for that device. We've implemented it, it's called virtiofsd, and it's a vhost user process. So it's a separate process from your hypervisor. You can use it with QEMU. You can also use it with other hypervisors that support the vhost user protocol. And it's sandboxed, so when it starts up, it makes sure that the only files available to that process are the shared directory and nothing else. It can also communicate with QEMU in order to set up shared file mappings. And this is some of the advanced functionality that a network file system wouldn't be able to do. So virtiofs is able to take a file and map it into the guest memory. Memory space, not into guest RAM, into the memory space. So you don't have to copy the contents of files into guest memory. Instead, the guest can just directly access files from the host page cache. And finally, it supports remote storage, it supports local storage. So what you put underneath virtiofs, it's just a pass-through file system. It could be an NFS mount if you want, or it could be a local XFS file system. Okay. David?
Thanks. For our implementation of the daemon, we started with two existing parts. We started with libfuse's library, which provides the code for pulling apart and building Fuse messages and interpreting them. And then it provides that to an abstract interface of a file system. And again, from libfuse's distribution, we took the pass-through LL example file system, which provides a backend pretty much straight through to a POSIX backend. From QEMU, we took libvhostuser, which is a library that provides transport over virtio using the vhostuser transport. vhostuser is a transport which takes virtio messages and parses them in an external process to QEMU. And libvhostuser does all the setup and the handling of the protocol over a socket which does the vhost setup. The libfuse library is not ABI compatible with the existing libfuse because we've had to go in and wire in the different transport. And we've modified the backend file system to add some threading as well. Now that's just one potential implementation. There are other ways of doing it. You could go off and use something other than POSIX as the back end. For example, there are existing fuse daemons that instead of talking to a POSIX file system, go off and talk to a network file system directly. Or you can go and speak to some block storage via user space in the external process instead, which I believe is being talked about in the next talk. Or you can go off and do other implementations. There's a Rust implementation in CrossVM, but it's not using vhost user as the communication with QEMU. We're looking at how to wire the two bits together at some point. Now, one of the tricks that we can do using virtiofs is to map parts of the file from the host file system directly through into the guest. And this saves any copying, and it also saves on buffer cache, because on a really good day, you've got one copy of the file sitting in memory. Now, the way we do this is that the Fuse client, that's the guest kernel, sends a message to the host over virt.io asking to map a section of a file, which is already opened using standard Fuse commands. The daemon then opens the file descriptor and passes that to QEMU, that then mmaps that file into a chunk of memory. And that memory is exposed into the guest on our PCI implementation as a part of a PCI bar in the guest. These mappings are allocated by the guest driver where it would like the mappings, and that makes it a lot easier than giving the mapping job to the daemon. One of the problems is we've got a finite size window here, so we can't map all of the files that you have open. We've got to allocate and reuse. So what are the differences from normal Fuse? Well, instead of using dev Fuse, we've got our own transport, or a vhost user, and that means we can't use standard libfuse daemons. We can't also just package up the messages and stuff them over libvhost. There's some security inversions that we only realized after we'd started. In a traditional Fuse system, the kernel that's providing the Fuse messages is the trusted part of the equation. The daemon is typically a user process that's running under the control of that kernel. In our environment, it's inverted. The kernel in this case is the untrusted guest. Our daemon is running on the host and providing access to the file system. So we've got to be completely untrusting of the guest. We've got to check all the paths, don't try and do escapes, and we really lock it down, sandbox, set compt, everything. Another thing we've got to deal with is reboots. In a traditional Fuse system, since the daemon is running under the kernel, if the kernel reboots, well, the daemon has to restart. In our world, the guest can reboot, maybe cleanly, maybe uncleanly, maybe somebody just echoes beta sysrec, or you mount and remount it. And the daemon has to handle that, which is something a traditional Fuse daemon doesn't have to do. Here's some pointers how to get it, and some example command lines, which you can cut and paste later at your leisure. Now here's some benchmark measurements that Vivek did, and the link to the data is at the bottom. In pretty much all the cases, even without the DAX, so that's the red bars, we're a little bit faster than 9p. And with DAX, we're a lot faster. There are some cases where DAX is a little bit harder. So most of these cases it's faster, but if you have a look at the rand read multi, you can see the DAX case is a little bit slower. And the problem we have here is that there is some latency in the guest saying, hey, I'd like to mmap this part of the file. So it sends a request up to the daemon opens the file, sends a request back to QEMU that mmaps it and then carries on. So there's some work we've got to reduce that latency and look at heuristics for trying to map what we need early. No?
So I'm going to talk about the specific part of this problem of improving performance of the virtiofs. That's how to deal with caches, or at least data cache was already introduced by Dave, but we have other kind of file system caches like metadata and path name lookup. And each file system operation will, if not cached, it will cause at least one, but usually more than one round trip between the host and guest to be able to perform file system operation. So caches are critically important in providing good performance. So if metadata and path name lookup cache can be shared with the host kernel, unlike data cache. So if it's not shared, then we need to have some way of invalidating the guest caches. If that cache invalidation is synchronous, then we have strong coherency. So if an operation that changes a directory or some metadata on a file only finishes when all instances of the caches have been invalidated, then we can provide strong coherency between all the guests and the host file system. If we can only provide asynchronous invalidation, then that will be weak coherency. It doesn't guarantee that changes are seen from all guests at the same time. If invalidation in a guest can block, then malfunctioning guest can cause denial of service, because for synchronous invalidation, that will cause the actual file system operation that changes the file system to block. So one way of implementing synchronous and non-blocking invalidation is to have a piece of shared memory containing a table which has a version number for each file. If the file metadata is changed, or for example directory contents are changed, then the version number is incremented, and the same piece of memory is seen by all the guests. So this version table is shared between the guests, and is also seen by the server, the virtiofs. And if some files is changed, then a version number is incremented. And this will have, so when the guest file system is looking up certain metadata or path name lookup in the cache, it can validate that cache very easily, because it can just compare the previous version with the one in the shared memory. And so it will be a very fast operation to check the validity of the cache. Currently, this is not yet working for changes made through the host file system, but but that's also something that for the future to implement.
Okay, and the current status, if you're wondering, because this fits in several components, is that the Virtio device spec itself is now in the Virtio spec. It has been accepted in 1.2. The Linux guest driver is in Linux 5.4, but the DAX feature is not included. That's a separate thing on top. And then the QEMU patches are being merged as well. The virtio-fs daemon is the last piece that we need to get upstream. But it's all available already on the virtio-fs website. So that's the end. Thank you very much.
So you probably won't like this question, but any work on drivers for other operating systems like Windows?
So for Windows at the moment, there are no Virtio drivers for virtio-fs yet, but we hope that they will exist soon.
So you were mentioning that because you use version numbers, you can't have the same mechanism being used for the host file system. So how would you plan to address that in the long term, and in particular in the case where the host, as you said, could be on the network file system?
Okay, so there's two parts to this. So if you have a network file system that does have coherency features in its network protocol, so it can do notifications, then it would theoretically be possible to wire it all up, so all the way through the guest down, that we could get a level of coherency. Of course, that's going to have overhead if the network file system, because you're going off the machine. That's one thing. I think the other thing that might be interesting to people is that we've been thinking about how to solve the problem of if the host itself, if processes on the host are modifying the files that the guest also wants to see, how can we make that coherent as well? And one of the interesting things now with the mdev developments that are happening is we might actually be able to reuse the vhost user device and mdev to essentially just share the same code and attach the virtio-fs device on the host as well. So they are all going through the same code path, and they're all using the same shared memory data structure. So that's what we're hoping to do, but we haven't started work on that.
So that means you would have to mount it in a special way in order to... You'd have to mount it on the host side in a special way in order to get that.
Right. So that's when I haven't looked in detail about how to do that. I mean, there are possibilities like to make sure that in that mount namespace you do a bind mount on top. So your processes and for the user, it looks like those are just their local files. They don't need to go to a different directory.
Okay. So you are not thinking about adding version numbers to VFS or whatever.
I didn't hear that. I'm sorry.
You are not thinking about adding version numbers in VFS or stuff like that?
No.
Hi. You didn't mention live migration in your talk. Are there some caveats and some things to address?
So yeah, there's a few different parts to live migration. We've not started looking at it yet, but my hope is to use the code from Creo, which does process live migration, on the hope that it's probably already got code for dealing with migrating file descriptors, and we've got a pile of file descriptors to migrate. Other than that side of it, the vhost part of the migration should be very similar to migration of vhostnet or anything like that. So I think it's really just a case of getting the file descriptors across, except when we talk about DAX. So we've got to figure out how to do the DAX side of it. But the non-DAX side, I think, is just a matter of moving the file descriptors across and abstracting it on the daemon. That's assuming that the hosts you're migrating between have a shared file system backing them. If they don't, life is more interesting. If they've got some type of rsynced one, then yeah, that's much more interesting question. But I'd start by looking at something like Creo and going from there.
Thank you.
Okay, we have time for one last questions. If there is no, thank you.